Hello everyone. In this session, we are going to talk about projectile motion on an inclined plane. Okay, so we have our inclined plane like this. Okay, it is inclined at an angle of alpha with respect to the horizontal. And in this projectile motion, we will take this as a starting point A from where we are throwing the object. And when we throw the object at a certain angle, it will follow a certain path like this. Okay, and eventually it will reach the point B. Okay, so this is our projectile. Okay, now how it is different from the projectile motion that we have already seen. In our projectile motion, usually we throw the object from the ground and the object again reaches the ground. For example, here if I have seen like if I see like that, I will throw the projectile, it will come back to the same level. But here it is not the case. Here it is going having certain displacement in y direction. Here the total displacement in y direction is 0 in this case. Okay, but here it is not. And let's say this angle at which the projectile is thrown, okay, is angle theta. Okay, so this is the angle at which the projectile is thrown. Now, in such a projectile motion, what we have to find out is the range, that is capital R, and the time of flight, capital T. So let's do this, okay? But before we do this, okay, we will take one approach. One approach. In this approach, what we are going to do is that we are going to take this axis as x-axis and this axis, okay, let me erase this axis as y-axis. So my reference frame is tilted by an angle alpha. Now since we know what is the projectile motion, how does it take place on a horizontal, we can just apply the same concepts to this tilted reference frame. Okay, so that will make the problem easier. Now let's do this. Okay, let's find out the time of flight first. Now what is the acceleration over here? Suppose if I take this point, okay, at this point I have acceleration due to gravity downwards g. Okay, now here I can make two components. One is vertical like this. Now look, our vertical is like this, downwards is negative, we will take, upwards is positive. Okay, now the vertical is g is vertically down, but our vertical in the reference frame is like this, so let's call it as gy, and another component will be like this, which is gx. Now what is this angle? This angle. So if I take this and transpose it here, if I can see like this is g, this is gy. I am just translating it here. What is this angle? This angle will be 90 minus alpha. So this angle will be alpha because this whole angle is 90. So this angle is alpha. And then gy is nothing but g cos alpha. And gx is nothing but g sin alpha. G sin alpha. So these are the two components, okay, of the g, that is the acceleration due to gravity. Okay, now let's solve the problem. Okay, first we will use this equation. Okay, y minus y0 is equal to ut uy t u0y, sorry, not uy, this is u0y, that is the initial velocity. Let's say initial velocity is u0. Okay, so u0y t plus half at square. Now let's put the values. Y minus y0 will be 0 because the total displacement in y direction is 0. See, here this is having y coordinate same as that of the point B. Point A and point B has the same y coordinate, so total displacement in y direction is 0. So this is u0y t. Now what is u0y? u0y is initial velocity along y direction. So that means this component, which is u0 sine theta. Okay, so This is u0 sine theta, this times t plus half. Now, what is the y component? Y component is g sine alpha. Sorry, g cos alpha. So here it is downward, so I am going to take it as negative. So this is minus g cos alpha into t square. So this will become u0 sine theta into t is equal to half g cos alpha into t square. Now t and t cancel and we get t to be 2u0 sine theta divided by g cos alpha. Okay, so this is our time of flight. Okay, so here I will write capital T for time of flight. So time of flight is 2u0 sine theta divided by g cos alpha. So this is the time of flight. Now let's find out what is the range. Okay, range means the total distance covered in total time, the total horizontal distance covered like this in total capital T time, that is the time of flight. Okay, so we are going to find out that. So let's do this. Okay, so what is the range? Range is the total distance covered in the time of flight, total horizontal distance. So what is the total horizontal distance? This is the total horizontal distance. So now what is the motion in the x direction? The motion in the x direction in the original, like this particular case of the projectile motion, the motion in x direction is a uniform motion. It is not an accelerated motion. But here in this case, there is an acceleration in the x direction. Basically, it is a negative x direction to be precise. This negative acceleration is nothing but a retardation. So there is a retardation in x direction. We have to take into account that. So now in the x direction, there is a gx acceleration in the negative direction. So this is not a uniform motion anymore. It is a accelerated motion. So to find out this, we will use again the same formula, but this time we will use u0x times capital T minus half g sine alpha times t square, minus because of its direction. So here u0xt, this is the range capital R, u0x into t, u0x is nothing but u0 cos theta. So let me write it directly. u0x is u0 cos theta. Let me erase that and write u0 cos theta into the time, which is time of flight, to u0 sine theta divided by g cos alpha minus half g sine alpha into t square. What is t square? 2u0 sine theta divided by g cos alpha whole square. Okay, so now let's do this. So this will become 2u0 square sine theta into cos theta divided by g cos alpha minus half g sine alpha into 4u0 square sine square theta divided by g square cos square alpha. Now let's take something common. Let's divide this g with the g and g square. I have cancelled one of the g, and here I will take something common. So I can see sine theta and 2u0 square can be taken as common. So I will do that. 2u0 square sine theta, and I will take g cos alpha as common. So here we get cos theta minus here sine alpha into sine theta divided by cos alpha. So let me take cos alpha, this one also outside. So it will become cos square alpha. And as a result, I have to multiply by cos alpha the first term. So here I have to multiply with cos alpha. So let me rewrite this properly. Cos theta cos alpha minus it was sine theta into sine alpha. So here this is 2u0 square sine theta divided by g cos square alpha into cos of theta plus alpha. So this is cos of theta plus alpha, because cos theta into cos alpha minus sine theta into sine alpha is this. Okay, so we have got this answer for the range. This is the range of the projectile motion. And we have already found out the time of flight, which is this.